Okay, this is 7th grade lesson 3.7. Our objective for this lesson, students will use the formal definition to identify direct variations. They will also solve word problems that involve direct variation. They will solve for the constant and write the direct variation formula using that constant. The standards in this lesson, once again, are 7 RP 2A, B, C, and D. The hardcover book page numbers are 138 through 141, and the practice journal pages 79 through 82. You will also be using a word problem worksheet with this lesson. Okay, so first of all, the definition of direct variation is a relationship between two variables in which one is a constant or a multiple of the other, also known as, if you pay attention, as one of your numbers increases, the other will also decrease, or the opposite, as one of them increases, the other will increase, and then also the opposite, if one decreases, the other will also be decreasing. So when we work through and we look at a table or a set of numbers, in order for a table or a set of numbers to have a direct variation, it has to follow the format of y equals kx, where k is a number that is not 0. And that's what we call the constant number. So when we did our activity for this lesson, that was our slope, or the change that was constantly changing from one point to the other. In order for a set of numbers to be considered a direct variation, they have to create a straight line. They also have to pass through the origin, or 0, 0. So this is just an example of a table that is showing direct variation. And then here's where I've graphed those points, showing what it would visually look like to see it as an actual picture of a direct variation. So we have a straight line that is cutting through 0, 0. And you'll notice here that in our equation, we were able to set it up and solve for k. So for example, if we wanted to solve for k on this one, we would substitute in 3 where our y is. So 3 equals, we don't know the k, but we know that x is 1. And then if we go through and we solve for k, we would divide by 1. Divide by 1, we find out that k is 3. So those are some things that we'll actually be working with in this lesson, is identifying from a table as well as identifying from a graph and an equation direct variations. Okay, so here we're going to tell whether x and y show a direct variation, and we're going to go ahead and graph these out. So you guys will use your whiteboards that you have to graph out these equations. Your graphs are a little bit bigger than mine. So we'll go ahead and graph this out. So the two things that we must have is we must have, when we have a graph or a picture, it has to cut through 0, 0, and it has to be a straight line. So those are the two things that we need in order for it to be considered a direct variation. So we'll go ahead and graph these. So when we graph these, this set right here is the same as saying 1, -2. So that's our set of coordinates. It's just a different way that they've set up a table. This next one would be 2, 0, and so forth. So we're going to go ahead and plot these. So I'm going to go over to 1, down to -2 and put my dot. Over to 2, up to 0. So over to 2, stay at 0. Over to 3, up to 2. And over to 4, up to 4. So we'll notice we do have a straight line. So it does meet that qualification that it is a nice straight line, but it does not cross through 0, 0. So tell whether x and y show a direct variation. This would be a no, it does not. Okay, and if we were to go through and substitute in and see if we can solve for our k, well, that's going to be our slope. So it doesn't mean that we won't have a constant, but it has to cross through 0, 0 in order to be considered a direct variation. So we don't even have to go through and solve for our rule. So we're going to go ahead and do the next one. If we plot this out, well, we're going to go over to 0, up to 0. So we can see that it's already passing through our origin, over to 2, up to 2, over to 4, up to 4, and over to 6, up to 6. So we also have our straight line. So this would be a yes. It is showing us a direct variation. And to figure out what our constant is, well, our x, if we go through and we substitute all of this in, I'm just going to show you one way that you can solve for your constant. We're going to plug these in. So our x is 0, our y is 0. 2, 2, 4, 4, and 6, 6. If I were to go through and say, what was I doing to the first number to get the second number? Well, I can't really test it on 0 because anything times 0 is going to give me 0. So I'm going to have to work with this first one here. So 2 times 1 would give me 2. 4 times 1 would give me 4. 6 times 1 would give me 6. So in other words, our constant is times 1 or just a 1. Another way to do that is to take a set of your variables. So we'll just work off of our 6 here. 6, 6, and we're going to substitute in. So our y was 6 equals, we don't know what k is, but our x was also 6, and now we'll solve for k. Divide by 6. Divide by 6, k equals 1, and notice how we already had that there. Okay, so that's just a couple different ways that you can solve for k, and we'll be using that second method a little more when we review through this lesson. Okay, so now you're going to go ahead and take out your worksheet that you have for this. And for each of these problems, we're going to answer the question that's stated. Then we're going to state the constant, or in other words, solve for k. And we're going to write the equation substituting in for k. So I know this is kind of small on your screen, but you have the worksheet so that it looks a little bit bigger. So it says y varies directly as x. So they're just telling us it's a direct variation. If x is equal to 5 and y is equal to 12, find x when y is 30. So we're going to set up a proportion. Now, I like to do proportions with the first bits of information as my first fraction. That's not the only way to do it. You could do x equals y or 5 equals 12. I'm going to set those two up as a fraction of 5 over 12. And that's where my top number was x and my bottom number was y. Now, probably a better idea to reverse those, but if you set it up this way, you'll still be able to go through and solve for your x and y. But usually we're used to having, when we do slope, our rise over our run. But we can go ahead and set it up this way. Okay, the third bit of information says find x when y is 30. So if our y is 30, well, on my bottom is where I had the y's. So now we're going to go ahead, cross multiply, divide to find out what our x would be. So 30, and this is reviewing stuff that we've done previously, 30 times 5 is going to give me 150. And then 150 divided by 12. So divide by the third gives me 12.5. Okay, so I just found out that x equals 12.5, so that's solving the first problem. The next thing is they want us to solve for the constant, or the k, by filling in our known x and y and solving for k. So I'm going to use the original statement here and substitute in. So our original equation, I'm going to write right below here, is y equals kx. Okay, so we're going to go ahead and we have to solve for our k. So we're going to substitute in, well, y was 12 equals, we don't know k, but we know that x was 5. Now, if I want to work to get k by itself, we'll divide by 5. Divide by 5. K equals 12 divided by 5 is 2.4. Okay, so there's the second one, solving for k. And then the third box asks us to write that equation. So we're going to substitute in our 2.4 where k is in the equation. We're going to leave y and x as they are. So y equals, our k is 2.4 times x. Okay, and this is what we would be using if they wanted us to graph out that equation. We could go through and pick different x's and solve for y. But we know that it is directly varying by 2.4 every single time we have a different x. Okay, so number 2, it says Heather's weekly pay is directly proportional to the number of hours that she works at the record store. Her pay, which we're going to use for y, is $174 for 24 hours x of work. So $174 for x, which would be her work hours, 24 hours. And I'm just putting the label off to the side. Find the amount of pay that she gets for 40 hours of work. So our second bit, or our third bit of information, is 40 hours of work. So now we'll go ahead and cross multiply, divide. So 40 times 174, and obviously this isn't the only way to solve it, but I wanted you to work proportions, reviewing what we've learned previously. So 40 times 174 and divide that by 24 gives us $290. So she's going to get $290 for that 40-hour week. The next part, solve for the constant K by filling in the known X and Y. So I like to use the one where they've already given me that, just in case I made a mistake in my proportion answer. I shouldn't get the second one wrong if I use the information that they gave us. Okay, so Y was 174. So remember, we're going to use this equation, 174 equals, we don't know K, but the X was 24 hours. Okay, so now we're going to work to get K by itself. So divide by 24. Divide by 24. We get K equals 174 divided by 24 gives us $7.25. So in other words, she's getting $7.25 an hour. Okay, that's our rate also. And we could have also gotten that here. You'll notice that that's what I ended up doing, is finding the slope or the rate. In our third box, we're going to go ahead and substitute in. So Y equals, our K was $7.25. And then we would substitute in for X. So for example, why would we ever use this? Well, maybe I want to find out how much she would get for a 50-hour week. So then I could figure out her Y is her pay equals $7.25 times 50 hours. So I could punch in 725 times 50 and find out that she's going to get $362.50 if she works a 50-hour week. Okay, so that's where you're going to be using that direct variation equation, is sometimes they're going to have you actually plot out. Okay, so let's do one more. It says, Eduardo counted 10 seconds between seeing lightning and hearing thunder, and he knew that the lightning was 2 miles away. Okay, so we went ahead and did our 10 seconds, and I'm actually going to jump to my next slide just so you can see what we're going to be doing. So this is the same thing, I just didn't put my Y's and my X's in the number 3 like you have. So here I said 10 seconds, this was our Y. And then between hearing lightning and thunder, and he knew that lightning was 2 miles away, so this was our X, was our 2 miles. Okay, so our Y is 10 seconds, so I'm going to do Y over X. So 10 seconds over 2 miles. Okay, the third bit of information, if he counted for 4 seconds between the next flash of lightning and thunder, about how far away was that? So our seconds we have as our top number, so we're going to put 4 as our top. Now we'll cross multiply divide, so 4 times 2 would give us 8 divided by 10. So 8 divided by 10 is going to give me 0.8 or 8/10 of a mile. Okay, so now we're going to solve for our constant. So I'm going to use my original X's and Y's, which were right here, and substitute in. So my Y was 10 equals our constant, which we don't know, times our X, which is 2. Just using that. So then to solve for K, we'll divide by 2, divide by 2. I find out that K equals 10 divided by 2, which is 5. So our constant is 5. So our variation is it's going to be times 5 every single time. So Y equals K is 5 times X. So now if I wanted to substitute in and figure out if I said it was 20 seconds away, I could substitute in 20 here, where Y is, because that was my seconds, equals 5x, and then I could divide by 5, and find out that it's actually 4 miles away. Okay, so that's kind of where we would go through and do that. So now what we're going to do is we're going to go ahead and pick some different X's and Y's. So we just found out that our K, this is the equation right here that we're going to use up here. So if you want to use this as one of your graphs on the back side of your worksheet, you can. So we've got Y equals 5 times our X, and we're going to substitute in for our X. So 5 okay, so maybe for our X's, we could do, I don't know, because our X's were our miles, right? So let's just do 1, 2, 3, 4, 5. So we'll do 0, obviously. Then we'll do a 1. We'll substitute in a 2, a 3, and a 4. So our x's are 0, 1, 2, 3, and 4. And then to solve for y, we're just going to solve this answer. So y equals 5 times 0, which is 0. So 0, comma 0. And then y equals 5 times 1, which is 5. So 1, comma 5. Y equals 5 times 2, which is 10. 2, comma 10. And then 5 times 3 is 15. So 3, comma 15. And then 5 times 4 is 20. So 4, comma 20. So now we're going to set up our graph. So our graph, well, our x's, these are always our x's, and that was our miles. And our y's, and I'm just pulling this information here, and I have it marked in your thing, is our seconds. And then we have to decide what we want each box to be worth. So for our miles, it looks like our x's went 0 through 4, so we could make each of these worth a box. Each box worth 1. So 0, 1, 2, 3, 4. And if you wanted to skip every other box, you could do that also. And then for our y's, it looks like we have to get up to 20. So let's see, 2, 4, 6, 8, 10. I think we could go every box is worth 1. I'm just going to mark every other one. So 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm going to have to go slightly off. 20, we're going to have to jump. We're going to have to go slightly off. So now if I go over to 0, up to 0, and I'm just plotting these, over to 1, up to 5, so there's 5. Over to 2, up to 10. Over to 3, up to 15. And over to 4, up to 20, which is up here. So you'll notice that we have a nice straight line. And that's graphing it. So here we could title this maybe lightning versus thunder. Because we're talking about how many miles away the lightning would be when according to the number of seconds of the thunder. Okay, so that's working with graphing our y-intercept equation, our direct variation equation. That's it. So the key thing to remember here is in order for you to have direct variation, it must have a straight line and it must cross through 0, 0. So when you're doing your second graph, make sure that you identify one of your numbers as 0, 0.